Hey guys, we're going to be looking at the Unit 4 test review, and I'm actually going to be looking at the multiple choice version of this. There's also a short answer version of this. Both are posted in It's Learning. But let's go through this. The whole unit is talking about inequalities and special cases of solutions. So the first few problems are going to focus on these special cases, which is what we did in 4.1. So it says identify the number of solutions of each set of graphed equations. This first equation, notice that it has one intersection point. The second set does not have any intersection points. And the third set has an infinite amount of intersection points because those two graphs overlay. So the correct solution here would be one solution, no solution, and an infinite amount of solutions. All right, and then it says, given the following system of equations, what would the solution for this equation be? So notice we actually solved this for you. And we solved using substitution. We gave you the two equations, y equals 3x minus 1 and negative 3x plus y is equal to negative 1. We took this 3x minus 1 and substituted it for y in the second equation, which is where we got this 3x minus 1 in our second equation. And by doing so, the 3x and the negative 3x cancel each other out, leaving us with negative 1 equals negative 1. Negative 1 equals negative 1 everywhere, so this is always true, which means there's going to be an infinite amount of solutions. Now, problems 3, 4, and 5 say match the following solutions to their solution type. The first one we have is x equals 4 and y equals 3. This is a specific solution, so that means it's one solution. It's a unique solution. Then we have 32 equals 32. This is true all the time, so that means it has an infinite amount of solutions. Then we have 5 equals negative 10. This is true none of the time, so there is no solution. That leads us into solving the following inequalities. So we're going to be looking at this. We're going to start off with a number line and solving for one variable inequalities. So negative 2x minus 4 is greater than negative 10. My first step is to add 4 to both sides. That's going to leave me with negative 2x is greater than negative 6 because I can combine like terms. My last step is to divide by negative 2. But remember your rules with inequalities. If I divide or multiply by a negative number, I must flip that inequality symbol. So instead of greater than, I now have that x is less than the value of 3. So this will be open circle at the value of 3, facing to the left because I want all of my solutions less than 3. And guys, remember, when I'm looking at inequalities or when I'm solving inequalities, I'm going to have an infinite amount of solutions because this is going to be a range of solutions now, not just a single solution. So we are going to move on to 4d minus 7 is less than or equal to 3d plus 3. I want to get all of my variables on the left and all of my constants on the right. So my first step is going to be to subtract a 3d from both sides. Now, you may not solve this in the exact same order I do, and that's okay. So I have d minus 7 is less than or equal to 3. Then I can add 7 to both sides. And as long as you wind up with d is less than or equal to 10, you are good to go. So the solution that best matches this is x is less than or equal to 10. Guys, our variables are interchangeable here. I apologize that I did not keep the variables consistent on my answer choice here. But if it is less than or equal to, this is going to be a closed circle solution. That means it contains the value of 10. Unlike number 6, it does not contain the value of 3. So it can be 2.99999 repeating, but it's not going to be the value of 3. That's not a solution to that inequality for number 6. But for number 7, it can be 10 and any number below 10. So everything to the left. Now we're going to go on to page number 2. It says create the inequalities based on the below and then solve for the variable. Anytime you see something that says a number, that means we're going to have a variable there. So I'm going to say x, subtracted is just the minus symbol, by 6, so I have the number 6, is at most the number 4. So let's talk about the phrase is at most. At most means it could equal it, but it can't get any bigger than it. So it must be everything less than or equal to 4. So my correct solution would be B there. X minus 6 is less than or equal to 4. For number 9, I've got the number 20 increased by. So that's going to give me 20 plus. So my operation for increased by is addition. And then 3 times a number. That's going to be 3 times some number that we don't know. So I'm going to say plus 3x. Then let's look at is at least. So I know it must equal it. At least means that's the lowest value it can be, so it has to be everything bigger than that value. So it's going to be 20 plus 3x is greater than or equal to the number 30, which is also going to be answer choice B. Now we're going to be looking at this next one, which is going to be a linear inequality. 3x minus 5y is less than or equal to 10. Currently, it's not in slope-intercept form. So I need to subtract the 3x from each side. That's going to give me negative 5y is less than or equal to negative 3x plus 10. And then I need to isolate y by dividing by negative 5 on both sides, which gives me that y. But since I divide by a negative, I've got to flip that inequality so y is greater than or equal to. Negative divided by negative gives me positive, but 3 is not divisible by 5. This would be our slope, so we're going to leave it as a fraction. So I have 3 over 5x, and then positive 10 divided by a negative 5 gives me a negative 2. And this will be my inequality that I'm going to use for problems 10, 11, and 12. So problem 10 said, if you were to graph the inequality, will the line be solid or dashed? Because it has that equal sign underneath it, it will be a solid line. Then it says, would you shade above or below the line? Since it's greater than, we're going to shade above the line. And then it says, how many solutions does this inequality have? Anytime it asks this, automatically it should either be infinite solutions or no solution. Infinite, and the no solution really comes in when we're talking about systems of linear inequalities. But almost all inequalities will have infinite amount of solutions. And that is everything for problems 10, 11, and 12, which leads us into graphing the following linear inequalities at the bottom of page 2. In order to graph these, I need to have them in slope-intercept form, so I need to isolate y. I'm going to do so by adding a 4x to both sides of this linear inequality, which gives me y is less than 4x minus 3. This has a y-intercept at negative 3, and I had to have the slope of 4 over 1, which means I'm going to go up 4 and to the right 1, up 4 to the right 1, or I could go down 4 and to the left 1. Because it's just less than, it's going to be a dashed line. Pardon me there, guys. So I'm going to have a dashed line. And it's less than, which means I'm going to shade below the line. So all the y values and everything in between below this linear inequality. Our next linear inequality is x is greater than or equal to negative 6. Well, I know x is negative 6, 6 spaces to the left. But this is true for every y value, which makes this a vertical line. Because it's greater than or equal to, this is a solid line. And all the x values bigger than negative 6 will be to the right of negative 6. So I will shade in the whole region that is to the right of this vertical line. And this is how I would graph anything that is x is greater than or equal to negative 6. So any values in this shaded region will be a solution for this inequality. Let's go on to page number 3. So for page number 3, 15 part A is asking me to write these inequalities. So I got to identify my y-intercept, which in this case is 0, 4. I need to identify my slope, which I know that these are going by 2. So it's down 2 and to the right 2. If I do that, negative 2 over 2 also gives me a negative 1. And because it's a dashed and below, this is going to be less than inequality symbol. If I put it all together, I know y is equal to mx plus b. So in this case, I can say that y is less than negative x plus 4, where m is my slope and b is my y-intercept. Let's look at the second version. I've got 15 part B. My y-intercept is at 0, 1. And make sure that you're writing your y-intercepts as ordered pairs. Then I'm going to look at my slope. I'm going to go up 2 and to the right 1. So these can be written as fractions or as whole numbers. My inequality symbol, I have a dashed line. and I'm shaded above. So dashed and above is going to be greater than. So putting it all together, I've got y is greater than 2x plus 1. And that's how we would write those inequalities for problem 15. Next, we're going to move on to systems of linear inequalities. So in order to solve any system of linear inequality, you must graph these linear inequalities. So the first line I have is y is greater than or equal to -4. This is going to be a solid line because it's equal to it, and I'm going to shade above. So I've got where y is -4. This is true for all the x values. So this is going to be a horizontal line. And I'm going to make that horizontal line. And I'm going to shade above that line, but I'm going to wait just a little bit to shade above the line. Then, apologize about that, guys. My little man does want to go trick-or-treating. Then I'm going to look at the next linear inequality, but this is not in slope-intercept form yet. So the first thing I need to do is subtract a 20 on both sides. I'm left with 4y is less than or equal to -8x minus 20. My last step here is going to be to divide everything by 4. And that leaves me with y is less than or equal to -2x minus 5. This also will be a solid line because it is equal to the line. And the shading is now going to be below this line. So any of the values on the line itself will be included in the solution. So I start at -5. I've got a slope of -2, so I go down 2 into the right one. Or I could go up 2 into the right one. And this will be a solid line. I'm not going to draw it perfectly right now, but you guys get the gist. Now, I know I need to be above my horizontal line. So it's this whole region above the -4. But below, y is less than or equal to -2x minus 5. So this is going to be my left quadrant. That's below the blue line and above the red line. A solution will be anything that falls within this region, so I can just say a solution is like -8, 0 in this case. And now I need to look at this next one. Problem 17 is writing inequalities. So my first inequality is the red line here. And I've got to look for that. We're doing the same thing that we did back in problem 15, parts A and B, except now we're looking at them on the same graph. So my y-intercept for inequality 1 is at 0, 4. And notice that these both intersect at the y-intercept, so I can go ahead and put the y-intercept for inequality 2 also at 0, 4. Then I'm going to look at the slope for inequality 1. My slope goes up 2 into the right one, which will just give me a slope of 2. And this is a solid line, shaded above. So solid and shaded above will give me greater than or equal to, giving me the inequality of y is greater than or equal to, excuse me there, y is greater than or equal to 2x plus 4. Now let's go to inequality 2. So inequality 2, like I said, we started at our y-intercept of 0, 4. But now I've got the slope of down 1 to the right one, which also gives me a slope of -1. But if I'm looking at that inequality, so looking at this inequality here, I know that I have a dashed line and it's shaded below. So dashed and shaded below is going to be less than, giving me that y is less than -x or -1x plus 4. All right, and then that moves us on to problem 18. Now for 18, I'm going to plug in these values. So anywhere I have a y for a, I'm going to plug in 1. Anywhere I have an x, I'm also going to plug in 1. So now I've got y is greater than 4 times 1 minus 3. So that gives me that 1 is greater than 4 minus 3. Is 1 greater than 1? That's not true. So that would not be my solution. So I can move on to the second point. And I'm going to plug in those x and y values again. I have -3 for my x value and 2 for my y value. So let's plug those values in. I've got 2 is greater than 4 times -3 minus 3. So that's going to give me that 2 is greater than negative 12 minus 3. And is 2 greater than negative 15? Absolutely. So this would be my correct solution, but let's go ahead and look at C just so that we can double check, make sure we've got the right solution. I'm going to plug in the negative 5 for my y value and 0 for my x value. So that's negative 5 is greater than 4 times 0 minus 3. Negative 5 is greater than 0 minus 3. Is negative 5 greater than negative 3? No, it is not, so that is not a true solution for that inequality. Which moves us on to problems 19 through 22. So it says, given the graph below, so I'm looking at the system of linear inequalities, determine if the given points are solutions of the graph. So we're going to start with the point 2, 4. Right 2 and up 4. This is not in my shaded region, so it's not a solution. Then we're going to move on to negative 2, 6. I go to the left 2 and up 6, but this is on my dashed line, so it's not a solution. I go to the point negative 8, negative 6, so I go to the left 8 and down 6. This is right in my shaded region, so it is a solution. And then I go to the point negative 6, negative 8, which lies on my solid line, so it actually is a solution. Let's go on to problem 23. Now, guys, I'm going to show you a way to do this using a system of elimination. So I know that I need to have one solid line and one dashed line, because this one is equal to it, but this one is not equal to it. So I can go ahead and eliminate answer choice A because it doesn't have a dashed line. I also can see that I need to be below both of my lines. Notice that all of these lines are graphed in the same spot. If I look at answer choice B, I'm above the solid line but below the dashed line, so that can't be the correct solution. If I look at D, I'm above both lines, so that's not the correct solution. But answer choice C is below both of my lines, which would be the correct system of inequalities. And the last problem. We're moving on to problem 24 here. So this one is the one where people are having a little bit more issues with. So let's talk through it. It says Mary babysits for $4 per hour, and she also works as a tutor for $7 per hour. She's only allowed to work at most 10 hours per week, and but she needs to make at least $30 a week. Mom, so guys, that is me, baby. Sorry, guys, my kids are talking to me. But she wants to make at least $30 a week. So the shaded region, we're about to go Halloween. Bye-bye, baby. So the shaded region is actually where we are going to find where she is working 10 hours per week, but making that $30 a week. So that's her sweet spot here. Now, does she have to work all of the 10 hours? No, she just can work at most 10 hours. And does she only have to make $30? No, but she wants to make at least $30. So she can make above the $30, but she can't make less than it. And she can work 10 hours, but she can't work more than 10 hours. So the first question says, if Mary babysits for 6 hours, which is on our x-axis here, what is the minimum number of hours she can tutor for? So that's going to be represented by this red line here. This is our minimum value, so it's not quite 2. So I would accept any answer between 1.5 and 2 hours. So is that going to be a full 10-hour work week? No, it won't be. That's the minimum number of hours that she would have to work, though, to make that $30 per the week. Then it asks, is it possible for Mary to babysit for 4 hours and tutor for 7 hours? Well, she's babysitting for 4, tutoring for 7. That point is not in my solution. But also, 4 plus 7, that equals 11, and 11 is greater than 10. So that's definitely not a solution, and it's not a possibility. She can't work for 10 hours. And then the last question says, if Mary tutors for 3 hours, so here she is tutoring for 3 hours, what's the maximum number of hours that she can babysit? That's going to get us all the way to 7 hours. And remember, 3 plus 7 is equal to 10, which is the max number of hours that she can work. Guys, that's everything that is going to be on your Unit 4 test. Say good luck, guys.
Good luck, guys.
Have a great day.